Greetings fellow Earthlings and welcome to this tiny garage. When I started this project, I really didn't know much about these cars. I knew that, potentially at least, they go 175 miles an hour, and that sounded pretty cool. I also knew that they had this controversial Achilles heel called the IMS. Now this is the IMS, the intermediate shaft, and the problem specifically is with this little bearing in the end. And yes, that's definitely a thing you want to be watching for. But I know enough now to realize that this is not the most expensive problem that you need to be aware of on your Porsche 996 and 997 engine. In episode 17, before we got into the engine, I said that if we found bad things inside, then that would be the end of this project in its current form. Those bad things that I was talking about was bore scoring. Now to fix bore scoring, you have to re-sleeve the engine. And I had determined that for this particular car, the math just doesn't make sense. Now if this was a late model, low mileage, high spec, C4S that was once owned by Angelina Jolie and your granddad gave it to you on his deathbed, then yeah, maybe you want to re-sleeve this one, especially if you had it apart like this. But for this particular car, at every step of the way, what we found is that the engine really is in great shape and there is zero bore scoring. And so we're going to return this one to stock. As a self-confessed noob, how can I talk with any authority on the subject of bore scoring? Well, when I started these videos, there was two main reasons for it. The first one was I was going to make the videos anyway to help me know how to put the engine back together, and I figured that could be helpful for other people as well. And then the other thing, I was hoping if I could get anyone who knew what they were doing to watch my cringe fest, that they might help me if I was making any mistakes and point me in the right direction. And yes, you have all been tremendously helpful on pointing me in the right direction and giving me information that I needed. And I'm way beyond where I could have got without all of your help. Thank you so much. And one perk of that is I'm able to be in contact with some of the top engine rebuilders, Porsche engine rebuilders on planet Earth. And they keep giving me helpful answers to my stupid questions. Now, in addition to that, this cylinder block is produced by a company called KS Kobelschmidt in Germany, and the pistons are produced by Mahle, that we already know are in Germany. And so I emailed their offices there, and then I phoned their offices in America, which is in Wisconsin for these guys, and Michigan for Mahle, and spoke to their engineering and technical departments, and that was great to be able to put together some of these pieces. Also, subscriber Bernard McLake, you might not know this yet, but part of the information that you gave me really helped me piece together some of the other morsels of information that I came across. And that's another thing too, between dozens of Facebook groups, online forums in Australia, America, Canada, England, Ireland, you've all been so helpful. And so really, this video is a collection of all of those bits and pieces that I've tried to put together for us so that we stand a chance of enjoying these cars and getting some sleep. So what is bore scoring? Well, a bore is a tube, these tubes, and to score means to scratch. So what's scratching your tubes? Well, it's your pistons, and specifically it's the skirt part of the pistons. That's because this top part of the piston here, where the rings go, is ever so slightly smaller in diameter to allow the rings to do the sealing against the cylinder wall. But the skirts here, they are much closer to the actual diameter of the cylinder itself, and so when things go wrong, it's your skirts that are going to do the scratching. We're going to be talking today about the ferrostan and ferroprint coatings on the skirts of these Porsche pistons. But there are coatings for piston skirts from all kinds of manufacturers that offer all kinds of benefits. One thing that's important to mention is that some wear of your skirt is normal. For example, on these Porsche engine blocks, when they're cast from new, the tubes are not perfectly round. They have defects in them. And so the initial role of the piston skirt during break-in is to sacrifice itself in order to conform to the bore and provide a tight seal within the cylinder. In addition to that, and relevant to what we're talking about with bore scoring, is if things do go awry and there isn't enough lubrication available in the cylinder, or if you get dirt lodged in between the cylinder wall and the piston, the coating is supposed to sacrifice itself to mitigate any of the problems that might have occurred if that truly was metal-to-metal contact. Many of you have suggested in the comments that why don't I just go and get the skirts on these pistons recoated. And so I called dozens of piston manufacturers and piston skirt coating companies, and it turns out that there is no coating that is known to work with Lokasil. So I decided to go straight to the source and I called Mahle, and this is what they told me. I said, hey, can you recoat my pistons? And they said no. And the explanation was this. They said that when Porsche came to them to produce those particular pistons with that particular coating, that Porsche came to them with all the specs, and that Mahle just did that, and they had an arrangement for to pay for the tooling up front and all the raw materials and how much they were going to make of them, and that's that. And so that when Porsche decided to pull the plug on that particular design, Mahle had to stop production and was not allowed to offer it in the aftermarket, and it also wasn't allowed to divulge any of the secrets for how it was done, because Porsche were afraid that in the aftermarket that someone who figured out the ferro-stan or ferro-print process could make millions. And then in addition to that, both Porsche and Mahle want you to buy the thousands of pistons that they've already produced that are sitting on parts shelves all over the world.
If you're enjoying these videos and you'd like me to make more, the best way to tell me is to click that subscribe button.
For over 100 years, a very common material to make your engine block out of has been iron. And iron makes a lot of sense for that. Iron is cheap and it's very hard wearing. The downside to iron is it's heavy. And so for European sports cars, and these days really a lot of modern cars, aluminum blocks are the way to go. The lightness adds performance benefits, of course, but also fuel economy benefits. Now the downside of aluminum is that it's quite a soft metal and it has a hard time coping with the combustion chamber environment. And so over the years, people have come up with all kinds of cool ways to try to remedy that.
Hit the notification bell, it's up there.
Yes, please.
One solution that engineers have found to that problem is to use iron sleeves or liners and put them into the cylinders of an aluminum block to protect the aluminum from what's going on in the combustion chamber. But on European sports cars, you hear about three main processes: Alusil, Nikasil, and Lokasil. Now in each of those cases, the sil part of the word is referring to silicon, like Silicon Valley, the semiconductor. And so silicon is part of the silica family, which is glass, sand, granite. And I think you would agree that all of those items share the trait of being very hard. Now silicon also is special in the fact that it's a metalloid, which means that it is not a metal, though it shares some metal-like qualities. And one of those qualities is it will allow itself to become an alloy with aluminum. Now, when we look at all of these different solutions, really what they're trying to do is exploit that fact to make the aluminum more resilient in the combustion chamber. The first one of those we're going to talk about is Nikasil. Now the Nik part of that word is referring to the metal nickel, and the Nikasil process is an electrolytic process where the nickel and the silicon are plated onto the inside of the aluminum cylinder wall. Now that works well. You're going to find Nikasil cylinders on the air-cooled versions of these Porsches, and then also on some Jaguars and some Ferraris, and so probably not too bad, right? The downside of the Nikasil process is nickel is bad for the environment, and then also it's quite a labor-intensive way to do it, and that results in it being expensive. Next up then is Alusil. Now in Alusil, the entire block is made from an alloy of aluminum and silicon, and they put as much silicon into that aluminum as it can possibly cope with, and that does work well. The downside to Alusil is the alloy itself is quite expensive, and of course it's quite labor intensive, and so therefore yes, it's expensive. Next up is the one that we're probably most interested in, which is Lokasil. Now this engine block was made using the Lokasil process. Now to do that, at the time of casting, they have these special little sleeves that are 25% silicone and 75% a fibrous material that allows it to be made into the shape of what the cylinder will become. Then they put those into the mold, and the hot metal from the casting process burns off the fibrous material, and that leaves behind the silicone locally. And that's where that name comes from. Lokasil is from the silicone left behind locally at the end of the process. Now, the downside of the Lokasil process is you can't just pour the metal in. You need what's called slow squeeze casting, where they force the metal in under pressure. But the upside is it's done at the time of casting. It doesn't add a tremendous amount of time, it doesn't add a tremendous amount of money to the process, and so that makes it quite cost effective. And it worked well for years in the Porsche 986. Thank you, subscriber Bernard McLake, for this morsel of information that really led to a whole bunch of very interesting discoveries. And that is the fact that Lokasil came in two versions. Version 1 started with the Porsche Boxster back in 1996 and ran up to the middle of 2001. And then version 2 was a slightly cheaper version of that process that actually resulted in a harsher surface finish inside the cylinder. So that's just another part of the equation that we just have no control over. And it seems that these M96 engines were a really clever design, but over time, the compromise in manufacturing processes and materials used met the increase in power and the demands being put on that same engine design, and met in a perfect storm that results in us talking about bore scoring. If you'd like to know the production date of your Carrera, take a look on the driver's door here, sort of where the lock area is, and that sticker is there. And if you look in the top right-hand corner, it'll tell you the production month and year of your car. This car was produced in April 2001, making it a likely candidate for Lokasil version 1. It seems that there's not just one single reason for why one car might experience bore scoring and another car might not, but there is a combination of factors that together might explain why one car would experience bore scoring at 50,000 miles, where another car might not get any bore scoring till 150,000 miles. Now this engine also, while it is anecdotal evidence, does give hope at least that even on a very high mileage engine that the bore scoring problem is not inevitable. So let's take a look at some of those contributing factors to the bore scoring equation. At the beginning of these parts' lives, they were manufactured within certain tolerances, meaning that there was a minimum and a maximum measurement by which these parts would be allowed to get put into the engine. And so to look at that from a very simplistic point of view, if your engine was put together on the day when the pistons were kind of big and the cylinders were kind of small, then that would make your engine initially susceptible to the problem of bore scoring. The next element to consider is as these parts age, those original engineering tolerances are going to change. And we've witnessed that firsthand on the wrist pin bushings in these pistons. They had a little bit of play in them that would allow these pistons to move a little bit. Now if you add to that the known problem with these engines and their big end bearings wearing out, which we notice on this engine also, plus the fact that the con rod bolts are known to stretch. So that's three elements within the piston and the con rod itself that would mess with the trajectory of this piston and contribute to the bore scoring problem. Next up then is lubrication. We all know that your engine needs oil, and in this case keeping your oil clean and fresh is going to be particularly important. As your oil gets older, it collects all the different particulates that were running around in your engine, and in this case they can get lodged on the side of your skirt and contribute to the wearing of the cylinder wall. Now in addition to that, we talked about blow-by, which is where the combustion gases within the cylinder itself are able to escape past the rings and into the oil. Now, when it gets into the oil, it kind of dilutes your oil and makes it less valuable as a lubricant. And so that again is a contributing factor to why really good lubrication is important if you want to try to prevent bore scoring in your engine. This next one's pretty common advice on these cars, but it applies to all cars really. When you first start them up, they run really rich. The computer throws a bunch of extra gasoline down into the cylinders, and that helps a cold engine get going, and it solves a few problems in that regard. But even though gasoline and oil both come from crude oil, they display quite different properties. And putting an excess of gasoline down into your cylinder, it runs the risk of getting onto the cylinder walls and reducing the quality of your oil's lubrication. The M96 engine that's in this car was first introduced in the 986 Boxster in 1996, and originally KS Kobelschmidt produced that Lokasil block, and they produced forged aluminum pistons with a coating on the skirts called ferrostan. And then a series of things happened. European environmental laws changed, which meant that that ferrostan coating was not allowed anymore. And so that forced Porsche to change the skirt coating to a thing called ferro print. And at the same time, they changed piston manufacturer to Mahle. And Mahle put that ferro print coating on their cast aluminum pistons. And that kind of coincided with the release of the Carrera, which was using that same M96 engine, but with larger displacement and more power.
Hi, Michael Catapang.
With bore scoring, what the piston is doing is wearing away the wall of the cylinder, and that's opening up that gap. And if you open up that gap, it's going to allow the combustion gases into your oil, and it's also going to allow some of that oil into the combustion chamber, and it's going to get burnt, and it's going to come out of the exhaust as smoke. Now, these cars are known for having a bit of smoke on startup because they have a horizontally opposed engine. And so unlike an inline engine where the pistons are like this, when you turn the engine off, any oil that might be next to the piston and the cylinder wall is going to fall by gravity back into the sump. But on a horizontally opposed engine, that oil can get back into the combustion chamber, and so when you first fire it up, you'll get a little puff of smoke, and that's normal. But if you get continued smoke after that, then that can be a sign of bore scoring, because it's allowing excessive oil into your combustion chamber all the time. Now, on these cars, the bore scoring is known to start on bank 2, which is on the passenger side. And so the exhaust for bank 2 is actually on the driver's side. It's such a small space here, they have to wrap the exhaust around. And so the bank 2 exhaust comes out on the left-hand side. And thank you to Roberto at Toon RS Motorsports for explaining this to me in a way that I could understand. The reason why bank 2 is more susceptible to the start of bore scoring is because essentially this car has a bank 1 and a bank 2, a left and a right. And the pistons, which we noticed when we were taking the pistons apart, I made these diagrams of all the pistons expecting that there was like a different one on the left and a different one on the right, but they're not, they're all the same. And so essentially what Roberto was saying is the engine has a left and a right, but all the pistons are lefts. And so the right hand side, the bank 2, is at a disadvantage from the beginning, and it seems that that is where the bore scoring generally is going to start from. Another thing you want to watch out for, of course, is oil consumption. If your piston is wearing away at your cylinder wall and allowing oil to get burnt in your combustion chamber, eventually it will get bad enough that you'll notice. Now, these cars, according to Porsche, it's normal for them to burn up to 1 litre of oil for every 1,000 miles driven. Now, the gauge inside, from the bottom to the top, the minimum to the maximum, is about 1 litre. 1 litre is very similar to 1 quart, they're very similar quantities. And then each section of that digital gauge is about 1/5 of a litre. So you want to set your trip gauge and then keep an eye on it when you get to 1,000 miles. How many little bars got used up? And importantly, if over time you see an increase in oil consumption, that could be reason to look into your engine a little further. Forewarned is forearmed, as they say, and one way to kind of get a early warning as to whether something might be going on with your engine is oil analysis. You want to be doing this every oil change so that you have something to reference to as things might be changing, and you can try to interpret what that means. Now for this engine and what we're talking about here specifically, on that test from Blackstone Labs, there is a section for aluminum, and silicon. And so those would be things that you could watch for to see if the piston is being worn, and then the silicon from the wall of the Lokasil is being worn off and then being carried away into your oil. As you can imagine, if your piston is wearing away at the metal of your cylinder wall, eventually it's going to get bad enough that you're going to hear it. And that noise is going to be from deep inside the engine, and it's going to be rhythmical, and it's going to change its speed with the speed of the engine. And if you're able to eliminate any of the other possible problems that could be like that, like belts and auxiliaries, then bore scoring could be on your list of possibles. When I first put the borescope into this engine, I only knew to put it into the spark plugs, but I know now, thanks to dropping a bunch of bolts into these holes, that you could put the borescope up here through the oil pan. And so this is bank 1, and you want to go up the bank 1 side hole and then get your borescope camera looking across here at the bank 2 cylinders in the bottom, where the skirts are and where the bore scoring is going to start. And then of course you want to come up the other side to look at the bank 1 cylinders. Of course, in the way here is going to be the bearing carrier, and so you're going to have to negotiate your gooseneck through to be able to look at the bottom part of these cylinders. So how do you fix bore scoring? Well, one of the real downers of bore scoring is there is no band-aid, there is no easy fix other than thicker oil and turning the radio up. And so when you need to fix your bore scoring, you need to look at taking the engine apart like this and re-sleeving the cylinder bores. And I wrote down all the information here. I did the research on like the most common things that you might do, including what I'm going to do with prices. And so here we go. Now, first option, if you live in America, the top place to have your engine rebuilt would be LN Engineering. And so this price is if you take it all apart, like I've taken mine apart here, and then you put the 2 halves of your engine in a box and send it to them. That's what this price is. And so the price for that box, which is a handy service that they offer, they'll send you a huge crate, I guess. You put all your stuff in there, the halves, send it off to them, and that is $600 for that service, which I live in California, which is a long way from where they are. That's a good price, to be honest. All right, next up then is to hone and sleeve the cylinders, which is a job that they do all the time. They're very, very good at it. That is $5,400. Then we said shipping $600. The pistons, you need new pistons. That can be all different kinds of prices depending on what you choose. But if you went with stock like pistons, they're about $300 each, and that would be $1,800 on pistons. But when you have your engine rebored and re-sleeved, you can go up in displacement. And so LN Engineering offer a 3.6 or a 3.8, which you're going to get about 30 horsepower and 30 torques more approximately. There's a number of variables there, and you can do that without really changing anything else in your engine. The computer and everything will figure it all out. And so that's an option. If you're paying all this extra money, you can also get the reliability of the sleeving and some more power. Next up then is work that I have to do on mine too, and you would have to do no matter what. If you're just sending the case to them and you're putting it all back together, then you'd have to pay for new wrist pin bushings, which is $150, and then to get those wrist pins installed is another $150, and then that total is $8,100 to get it all back in your garage, ready to go back together. And the wait time, another downside of that, though it makes sense, it's 3 months, so you'll be waiting 3 months once they get it before you might get it back. Okay, next up, Hartech UK. If you live in Europe, then for sure, they are like the top Porsche engine rebuilder on planet Earth. From here, it doesn't necessarily make sense, though I love the company. because I'm like 12,000 miles from there, and then plus the conversion from English money to American money is terrible from the American side. But their price, I know from living in Europe, that the conversion when you're living there doesn't really feel like it exists. And so their price is similar to the LN Engineering price. And the service that they offer, again, is similar. But if you're in Europe, that would be your obvious choice to go for. And next up then, okay, a local machine shop. So with the local machine shops, almost every single one, all but two that I called, I might as well have farted down the phone at them because they're like, oh yeah, we don't work on that foreign stuff. I'm like, oh, okay, sorry. But the places that do, their prices are less. But again, LN Engineering and Hartech, they do this every day, and I know enough now that really it would be worth your while knowing quite a lot about these engines before you start trying to do something like this. Anyway, here's the price for a local machine shop that would do the same kind of thing as Hartech and LN Engineering on paper at least. And so they were saying to bore out the cylinders was $330. To sleeve the cylinders, sleeves are about $200 each. You've got some choices if you're doing this a la carte like this. But about $200 each, so $1,200 for the sleeves. And then to fit the sleeves into the block is $500. And then the pistons, which you need pistons anyway in these examples so far, $1,800, but you've got some choices there. You can pay way more than that if you get some fancy forged pistons. And then wrist pin bushings $150, wrist pin installation $150, and so that's going to cost you $4,130 to have a similar type of job done at your local machine shop. And then the turnaround there was less than a week, so that could be good, assuming that they can do a very good job. That would be great. All right, the next one then is if you just replace the pistons, and you would get some of the old stock from Mahle that had fresh skirts on them. Those pistons would be $1,800 again, approximately. You can get them a little cheaper, but approximately $300. They come with rings on them. And then wrist pin bushings $150, installation of the wrist pin bushings $150. I hope I said $150 both times. And so the total there to just put new pistons on would be $2,100. Next then, which is what I'm doing, which is putting them back as is. And it's important to understand that if you don't have bore scoring, that is definitely an option. And so putting them back as is, you need to buy rings for your pistons, which I did, and that's $290 for the 6 sets. And then your wrist pin bushings $150, your wrist pin installation $150, and then the vapor blasting of the pistons was $225. And then the tool, I got a better ring tool, which we'll look at in a future episode, and that was $16. So you'd have to buy that to make this all work out. And so that is $831 if you put them back in as is. So there, that's the roundup. Everyone has a different situation depending on what car they have, where they live, and the budget, obviously. And so that gives you an idea of what you're talking about. If you have bore scoring, then one of those is going to be in your future. So how do you prevent bore scoring? Well, I think we've learned enough by now to realize that so many of these factors are just outside of your control. First of all, it might depend on the production date of your car, for which version of Lokasil got used, which pistons you got, which type of ferroprint or ferrostan coating you got on your skirts. And then in addition to that, with a used car, of course, it will depend on who owned the car before you, how they drove the car, and how well they maintained the car. But assuming that you have the car now, there are some things you can do to try to at least slow the onset of bore scoring and give you an idea that it might be happening. So first off is a good one. You need to drive the car regularly. That way, every time you come back to the engine, there's still a little film of oil left behind and you don't have any dry starts. And in addition to that, you want to drive the car, not just start it up, warm it up, and then turn it off again. We were talking earlier about the rich fuel condition when you first fire up these cars. And so the idea behind just heading out there is to burn up that excess fuel so it doesn't have an opportunity to interfere with the lubrication of your cylinders. And so the advice would be turn your car on, Check that your temperatures and pressures are good, have a listen, get used to what your car sounds like when everything's okay, and then head off and drive like grandma until your coolant and your oil are up to a good temperature, and then, you know, go crazy. And finally, this problem is yet another reminder for why we all need to change our oil regularly. It is the simplest and cheapest way to keep these engines, any engine, running the way it should. Unfortunately, that's all we have time for this week. Thank you very much for watching. Till next time.